So in this video, we're going to review solving not only radical equations, but also equations with rational exponents. So kind of everything having to do with radical and rational exponents, I guess. So we're going to look at things like this. So something with a radical, just like a square root in it. What do you do if you have a rational equation or a rational exponent? And then what about these higher roots? So all of those things are going to be discussed in this video. If you are trying to just find one part, look in the description for time markers. Okay, so for radicals, in general, what you want to do is you ideally want to isolate a radical to each side or to one side. So it depends on how many radicals you have, but if you have two radicals, you want to just isolate to each side. And if you have one, isolate the radical to one side and then square both sides. And watch out, you might have to FOIL. So that's like the general strategy, but this can get kind of complicated. So I'm going to show you a few examples. Now, the other thing that you want to be careful of is you have to check your solutions. And it's not just out of, oh, check it to make sure it's right. Sometimes you have solutions that are erroneous, which means that they just don't work. So you solved it, but it doesn't actually work. So you have to watch out for that. So I'm going to show you a few examples. And we're really going to go through a lot in this video. So I'm going to go through it pretty quickly. So if you need a full lesson, check out the links to full lessons in the description, where I break everything down at a much slower pace. Okay, so let's get started with this one. So I've got x minus 3 times the square root of x plus 2 equals 2. So like I said, so what you really want to do here is you want to isolate the radical. Now, in the event that you have something like, say, a 3 in front of it, that's totally fine. That's not a problem. So then you can just isolate all of this, no issues. So to isolate that, what I'm obviously going to have to do is subtract the x to the other side. So this becomes negative 3 square root of x plus 2 equals 2 minus x. And then you're going to square both sides. So this is what I was talking about. And as far as like what to do next, so sometimes you could do this and you might just get a number here or just like one thing. And then like you could just get like a 7 here or something. And then that would be all that you have to square. But other times, so look at what it means to square this whole side. This does not equal, just to be clear, this is not 4 minus x squared. Not equal to that, okay? You have to actually FOIL this out because this part right here, this 2 minus x, that equals 2 minus x times 2 minus x. That's what it means to square something, right? If you ever run into that issue of you forget to square, like just write it out like this. Okay, so what I have to do then is I have to FOIL this side and square this side. Now, if you're watching this as a review, even if you get it wrong, I think you should at least try to square both sides because you will get the most out of this review if you actually try and participate a little bit with the video. Okay, so when I square both sides, so negative 3, this is in parentheses, so when I square it, it's really negative 3 times negative 3, which becomes positive 9. When I square a square root, the square root falls out, so then I'm just left with x plus 2. And then this other side, so like I said, I have to FOIL it, so this is going to become 4 minus 4x plus x squared. And now from here, ideally, what you can do is then just solve this as if it were a normal, equation. So I've got this as x squared right here, which means that I'm probably going to have to factor this or do something like factoring. So I can go ahead and distribute. And just in the interest of time here, so I'll go ahead and subtract 9x and 18 over to the other side to get x squared minus 13x minus 14 equals 0. And this does factor, right? So this can be factored as x minus 14 and x plus 1 equals 0. So I have x equals 14 and x equals negative 1. So this is the part that you have to be careful with. You do actually have to go back and check these two solutions. So just in the interest of time here, so I'm going to check x equals 14. So let me just show you the work that I would do. So notice that I plugged 14 into the original equation where I see the x's. And so if I work this out, this is all going to give me all of the work that you see here. So I wanted to just make sure you had the work. So I actually get that this does equal 2. So 14 is definitely a solution. So now let's try x equals negative 1. So if I try this now for x equals -1, now maybe you want to pause here and just check it yourself. So I'll show you what it looks like to just plug it in. So notice where I had the x's, I replaced it with a -1. So if I work all of this out, I get -4. And okay, so obviously we needed this to equal 2, not -4. So -1 is not a solution. So that's what I mean that you kind of have to watch out for. Okay, so I have one more example like this, kind of with a similar solving strategy. So I recommend, again, if you're watching this because you're rusty, I think you should pause the video here, try this on your own, and then hit play when you're ready. So what I need to do is I need to isolate this square root, so I just need to add the 9 to both sides. So this becomes the square root of 6x plus 7 equals x plus 2. And so then I can go ahead and I can square both sides, which thankfully will be a little bit easier this time than the last problem. So this gives me 6x plus 7 equals x squared plus 4x plus 4. And so then I have this squared here, so I'm probably going to have to factor again. So I can subtract off the 6x plus 7. So that's going to give me x squared, let's see, minus 2x minus 3 equals 0. And so then let's see, that definitely factors. So my two solutions are x equals 3 and x equals -1. So once again, I need to go through and just check them. So if I check them, if I try x equals 3, so once again, I have to plug the 3 in, but notice now there's an x on each side, so it might make it just a little bit more complicated to check, but it's not a huge deal. So let's see, if I just plug in 3 to this side, so I get this square root of 6 times 3 plus 7 minus 9. So if I work all that out, on the left side I get that the left side came out to -4. So that was just me plugging into the left side. So I still have to do now the right side. So if I plug in this 3 minus 7 on the right side, I also get -4. So the two sides are equal. So x equals 3 is definitely a solution. And so we can start over now with x equals -1. So let me clear some space. And again, like, I know that this probably seems maybe kind of simple, but sometimes it can mess with your head a little bit. So if you're not trying to check these on your own, highly recommend you try to do that. So let me show you what it looks like to plug in -1 on the left side. So I plug in -1 where I saw x, and if I work through all of this, I get -8. And then if I plug in -1 on the right side, I also get -8. So those two sides are equal. So actually, in this case, both are solutions. So you could have no solutions, one solution, all solutions. It really just depends on the problem. So now I want to just go through the harder type of example with this. So notice what this problem is. So I've got the square root of 3x plus 4 minus 5 equals the square root of 3x minus 11. So what makes this different from the last two problems is that I have two square roots. And so you might remember that I said if you have multiple square roots, the goal is to just isolate one on each side. But here's the tricky thing with that. In this particular instance, so I have this -5. Where does it go? So there's really nothing you can do with this. You can't simplify this like -5 anymore. So as long as you have one square root on each side in this case, yeah, that's as good as it gets. So now, what do? Well, it's still the same solving strategy in that I want to square the entirety of both sides. So if I square both sides like this, so the thing about this is, so this side it will be pretty easy to square, but this side, what do you have to do with it? You have to FOIL it, right? So if it's been a minute since you've tried to FOIL something like this, again, you know what I'm going to tell you. I think you should pause and just try that because, again, even if you mess it up, like nobody's going to know. Nobody cares. Making mistakes and then seeing how to do it right will just make it click so much better in your head if you try it. So I say pause, give it a go, hit play when you're ready. Okay, so I'm going to go ahead and just write out what this looks like foiled. So here's all the pieces of my foiling. And so if I collect my like terms, so let's see, this is going to give me 3x plus 29 minus 10 times the square root of 3x plus 4. And then the other side is just the squared 3x minus 11. So here's what everything comes down to. Okay, so now, like, back up for a moment, and we just have to think logically about what do we do. What are we left with here? This is now, like, forget about what we were doing before. We've kind of changed the game with this problem, and now I have a problem with one square root in it instead of two square roots. And what do you do when you have just one square root? Well, if you have one square root, then you want to isolate that square root to one side and then try to square everything again. So we have to repeat the squaring process. So what I recommend that you do is go ahead and so bring these over to the other side and try to, we'll see where you're at. So maybe let's do that first. So this becomes negative 10 times the square root of 3x plus 4. Let's see. Oh, the 3x's actually drop out. And so then I'm left with, what does this become? Negative 40, right? Okay, so in this particular instance, this makes sense. So you might notice that both sides could be divided by negative 10. So I'm going to do that. I'm going to divide both sides by negative 10. So this becomes the square root of 3x plus 4 equals 4. Now, you might be saying, but why didn't we divide by the number that was in front from the earlier problem? So let me just refresh your memory real quick. This was the first problem that we did, and I just want to maybe highlight, so this line here. So do you see how in this line here, when we first started and we just squared both sides, I could not easily divide everything by negative 3. So if I divided this side by negative 3, it would have created this like gnarly fraction. Not cool. We wouldn't want to do that. So in this case, I just let the number hang out in front. And in this problem, I can easily divide by negative 10, so I divided by negative 10. So you really just want to take the path of least resistance with this is what I'm saying. Okay, so now let's square. So I get 3x plus 4 now equals 16. Hey, that's really not bad, right? So this becomes 3x equals 12, so I get x equals 4. Cool. So now we just have to see, does that actually work as a solution? So if I just check x equals 4, so let's see, if I plug it into the left side, I'll get this square root of 3 times 4 plus 4 minus 5. So if I work that all out, I'm going to get negative 1. So now if I plug in x equals 4 to the right side, so let's see, what do I get? This is going to give me just the square root of 12 minus 11, so this equals the square root of 1, which equals 1. And we have negative 1 and 1. These are not equal, right? So no solution. Again. Okay. So that's kind of your crash course review of working with square roots. So like I said, if you want more review on this, I break this down in a lot more detail in some other videos. But now I'm going to just move on to a couple other types of problems. So what about for higher roots? So then what do you do? So usually with higher roots, these are going to be a lot easier. You're not going to run into something where you have to like cube something and then you have to like do this crazy multiplication. Like these tend to be a little more straightforward. So just to give you a little bit of a reminder, so with square roots, with something like this, I squared both sides. Therefore, with cube roots, to unravel a cube root, what do you think I do? I cube both sides. So that makes sense, right? And so if I cube both sides, so what ends up happening here is that I'm just left with, oops, let me change my color. I'm just left with 2x plus 1 equals 3x plus 5. No problem, we can solve that all day, right? So this becomes x equals negative 4. Oh, hey, I'm done, cool. And so then you can go ahead and check that one just to be sure that it works. So if I just check it real quick, I get that both sides will equal the cube root of negative 7. So I just showed all my work here. So if you want to pause the video just to double check it, you can double check it, but it's pretty straightforward and there's no problem with this particular solution. Okay, so then with cube roots, I cubed both sides. So with fourth roots, now what do you think I do? I take each side to the fourth power. And this is actually going somewhere, and this will lead us into our next topic. So if I take each side to the fourth, this becomes x plus 3 equals, let's see, 2 to the fourth is 16. And so then I can just subtract off that x to get that this is equal to 13, you can double check that that solution works. I know it works, so I'm just going to move on. But right, so you see the pattern. So cube roots, you cube both sides. Fourth roots, you take each side to the fourth. If it was a fifth root, you take each side to the fifth. So I think you've got it. So now we want to apply that logic to rational exponents, which are fractional exponents. Okay, so it's actually the same logic. So just as a quick reminder, maybe you remember this, maybe you don't. So the way that any root can be rewritten with a rational exponent, right? So when I said that for a cube root to solve it, so let's say I had something like the cube root of x equals 2, that would be equivalent to x to the 1/3 equals 2. And in both cases, we said that we cube both sides, right? So I just want you to notice the visual connection here. So this is the side I want you just to notice for a second. In cubing it, so do you see how the fraction ultimately drops out because you are multiplying those exponents? This logic applies to what we are going to do here. So let me clear some space. Okay, and so just to give us even more space, oops, let me change my color. So I have x to the 5/4 equals 32. So it's the same logic in that I want to really multiply by the reciprocal exponent. So to do that, I put a set of parentheses around it so that I can use the power rule, and I just use the reciprocal exponent. Now whatever I do to one side, I have to do to the other side. And this is probably also now a great time to also review rational exponents. Okay, so with the exponent rules, so what ends up happening is that these just cross out, so the left side just becomes x. And then what do I do with the rational exponent here? So the way that we think about this is we can think about taking the denominator and rewriting that as a root. And so the standard way that we approach this is we first take the root, so the fifth root of 32 is 2, and then we use the top part of the exponent. So this would then become 2 to the 4th. So just to break this down, this becomes 2 to the 4th, which equals 16. So x in this case would just equal 16. Okay, so for our next one, so this one's actually a little bit of a brain teaser. So for this one, so when you first think about this, so I've got 2x plus 1 to the 2/3 equals 36. And you might be tempted to just take each side to the 3/2. But there's actually a little bit of an issue with that. So let's actually review another property real quick, which is the square root property. So in general, if I have something of the form, say something like x squared just equals 36. Okay, so what the square root property says is that when you take the square root of both sides, this is actually going to be a plus or minus on this side. And so the answer should be plus or minus 6. So anytime you have an even power here, you always have to break it up into a plus or minus answer. The reason why that matters then here is because the top part of this exponent is technically a squared, right? So we actually do have that plus or minus situation here. So we just want to be a little more careful now in how we think about this. And if you want, you can go in steps on this. So what I'm going to do first is I am actually just going to take this 2/3. So I am going to take this to the 1/2 so that I get the 2's out of the way. But now in my brain, this makes a little bit more sense as to why I need to have this plus or minus here. So if this confuses you, you can go in like 2 different steps. So now what I've got here is 2x plus 1, all of this to the 1/3 equals 6, or 2x plus 1 to the 1/3 will equal -6. So I do have to break it into these 2 different cases. And now I can go ahead and I can cube both sides. But you can see now that this also splits into these 2 different answers. So now I have either, oops, let me switch my color here. So I either have 2x plus 1 equals 216, or 2x plus 1 equals negative 216. And now I can just solve as usual. So I'm going to go ahead and subtract 1. So I have either 2x equals 215 or 2x equals negative 217. And so then I can divide all sides by 2. Okay, now the only other thing that we have to do with this though is now we actually want to take a second to check if both of these solutions make sense. So let's make a little space. Okay, so let's make a little space, and so I've got the two solutions up here. So it's not going to be that difficult to check these actually. I know they look like they're fractions, but the nice thing is the 2 is actually going to cancel out. So if I take 2 times 215, 215 over 2 plus 1 to the 2/3, so what is that going to give me? That's going to really just give me 215 plus 1 to the 2/3. So that's going to be 216 to the 2/3. So the cube root of 216 is 6, and 6 squared is indeed 36. So we are all good there. And then if we do the other one, so I have 2 times negative 217 over 2 plus 1. So this is going to be then ultimately, what is this, negative 216 to the 2/3. And so then if you take the cube root of negative 216, that's negative 6, and then you just have to square it, and so that's still positive 36. So in this case, both solutions do indeed work. Okay, so we have now one more here. So I have one where we need to solve for a formula. It's kind of still in the same vein of problems though, even though it looks like a formula. So in this case, I want to solve for x. So x is covered in the square root, and so now it's just thinking of all the things that we've used so far. Now, in general, when you're solving for a variable, you want to isolate that variable. And so the issue here, right, is that I have this k here. So the first thing I'm going to do is I'm just going to divide everything by k. So I have the square root of x now equals y over k. And now to get to the x, I can go ahead and I can square both sides to get that x will equal y squared over k squared. So you always just want to isolate the variable in a formula and then just do whatever you need to do with the exponents to make it work. Okay, so if you're looking for a more complete review, I do have other videos. You can always check the description for other videos to that. But otherwise, I'm going to leave it here. If you found that helpful, I'd love if you hit that like button. And otherwise, I will talk to you guys in another video.